Hello everyone, welcome to this video. In this video I will show you how does k-means works. So the main idea of k-means is to allow you to divide a network into an optimized clusters. At the end of the video you will understand why k-means will choose this option as an optimized clusters rather than other options. These three options in our case would be called key classes. And key will define the number of classes that we want to have. So how does it work? So the algorithm is divided into steps. We will see after this step the remaining steps, and in general there are like 5 steps. The first step will be selecting the number of classes you want to identify in your data. And this is the key. In our case we will choose key equals to 3 just for the simplicity and for the explanation, but I promise at the end of the video I will show you exactly how do you choose the better key. The step 2 will be randomly select 3 distinct data points. 3 because we choose to have 3 classes. If we choose 4, 5, 6, then we will choose randomly 4, 5, 6 distinct data points. So here you can see that we have randomly selected 3 points, blue, and yellow, and orange. Those are called initial classes. What we're doing in the step 3 is to calculate the distance between each single node and those 3 randomly selected classes. We will do it first for the first node, then we do it second node, third node, and the last node. In this particular case, you can see that the distance 1 is less than distance 2 and distance 3, and therefore the algorithm will assign the first node to the first cluster, to the blue one. Step 4 will be assigning this point to the nearest cluster. In our case, it's blue. And step will be measuring the distance between the second node and the 3 clusters. So it's like a repetitive step that will be repeating till the last node. So in this particular case, you can see that distance 1 is less than distance 2 and less than distance 3, and therefore the second node should be assigned to the first cluster, not the second, not the third, because of the Euclidean distance. And this will be also repeat the step number 4, which is assigning the point to the nearest cluster, and we'll be doing this for every single node. And lastly, the step number 5 will be calculate the mean of each cluster, and this can be done using the equation of SSE, which is the sum squared error that is presented by the equation on the slide. You can see that the mean will be only calculating the distance between each node and the mean of the cluster, and here the mean of the cluster 1 is x1, the mean of cluster 2 is x2, and mean of cluster 3 is x3. So we will calculate the distance between node 1 and x1, node 2 and x1, node 3 and x1, node 4 and x1, and we will do the same for the second cluster, maybe between node 5 and x2, node 6 and h2, node 7 and h2, and so on till the last one. And we will have what we call the sum squared error that measures the distance between the mean and those nodes. Now, how do we choose k? It is very important that we choose an optimal k. And there is many options. I mean, you can start with k equals 1, and it is the worst scenario because the mean of the whole setup will be just like we didn't choose any cluster. We can choose k equals to 2, and you can see here, for example, I forgot to tell that in the first cluster, if we choose k 2 and 1, then every single node will be assigned to the one cluster, which is like the whole network will be considered as one cluster, and it is the worst case. For k equals to 2, you can see that nodes are assigned to 1 and 2, and that therefore the algorithm will show us something like this. K equals to 3, it gives us something like this. And we can go k4, k5, k6, and so on. Algorithm will divide it for us. So how do we do it? We do it using what we call the elbow method. And the elbow method simply will be at each k, we will measure the sum squared error. And as I said earlier, when you choose k equals to 1, which is the worst case, it will give the highest sum squared error. And then you will use 2, 3, 4, and so on. And you will choose the point. The SEC is decreased somehow linearly. So it's the point presents the drastical change in the SAC. In our case, we can see that 3 is the optimum one because it shows a huge decrease in SAC. After that, S4, S5, and 6, it's something that is nearly linear, and therefore K equals to 3 is the best choice. And you can see on the right, the algorithm that we have applied to a set of nodes, here 150 nodes, and the algorithm was able to divide the network into 3 clusters. I will be putting the algorithm in the chat just in case you want to try it. Thank you so much for having me today, and this is the end. See you in another video.